continue with chapter 4, right? Not on that page. Yeah, okay. We did this one, that's right. Here it is, we scheduling, remember the TV ad? What's going on? Everybody signed in? Everybody? Seriously. What's this saying? No class Thursday, is that true? There's no class Thursday? This is a mistake? Awesome. All right. Yeah, we gotta start all over. We're ready to finish, continue with chapter 4. I have my alarm set, so we'll have enough time to do our other class today. And our next example, we're going to try to get through 3 examples today, leaving us with 1 for a week from today to finish before we start chapter 6. Marketing research, another marketing one for those marketing majors. Are you ready? I've been in situations where we're trying to decide whether like to buy a piece of property or a new item, think about making, and we want to have some market research done to make sure that there's a demand for whatever it is we're doing. Well, we always hired a advertising firm or a marketing firm who specializes in marketing research. That's what's happening here. You're the marketing company. You have just been assigned a research project. You're meeting with the clients to figure out what the needs are, what's the objective of this market research, and they just told you that we started this, as it's all reviewed, just making sure. They told you there's 4 types of responses you want to gather for them. Please survey households that have children during the day, and survey households with children in the evening. And then there's also, they asked you to survey households with no children during the day and evening. So there's 4 different possibilities. And you told me that means there's 4 decisions that you have to come up with. What's the optimal amount of surveys to be done in each category? Because they told you there's to be 1,000 surveys total, right? 1,000 surveys total. And the objective from the client is keep our cost as low as possible. And right there's the cost of doing a survey in each of the 4 categories that we need to do surveys. Now there's a whole few more rules they asked. They said do 1,000 surveys, exactly 1,000 by the way. Is that a less than equal, greater than equal, or equal? Equal. That's right. Then they said interview at least 400 households with children. Now, how many variables are involved with households with children? Out of 4, 2, that's right. The variable that represents households with children during the day is one of the variables. The variable that represents households with children in the evening is the other variable. Now let's go back to the sentence. Interview at least 400 households with children. At least 400 means greater than equal 400, and the 2 variables on the left are the amount of daytime with households, the amount of evening with households. When we add them together, because they represent how many we're doing, they need to be more than 400. The client said at least 400 households without children. 2 variables again, right? The one without households in the day, households in the evening without children, added together, greater than equal to 400. Now, we skipped this one and we did these 2, and what was there was a phrase I said that you kind of need to, when you do these. And what it was is I said, write these out just as it reads, and then use logic or algebra to rearrange it. And how it reads is, at least 40% of. At least means greater than equal. 40% of means 40% multiplied by. The interviews for households with children. That means all the interviews for households with children, which there are 2 variables that represent households with children, day and evening. The other 2 variables are without children. So it would be 40% times those 2 variables added together are on the right side. The left side is 40% of these interviews conducted with children need to be in the evening. The variable that represents interviews, households with children in the evenings on the left. We did these already, and they're all right here. So that's why I'm not rewriting them all. So here's with children, we have to be over 400. Without children, over 400. We skipped this one for a minute. 40% of all the households with children, the evening ones need to be greater than that. You use algebra, you get a 0 on the right because you multiply, just like we did here. Where's that one? We took 50 times x plus y, you're taking 0.4 times dc, 0.4 times dc, then subtract them and get them to the other side. Here, the next one says 60% of the interviews of households without children need to be in the evening. Here's all the households without children, times the 60% of. at least. So evening, households with no children need to be greater than 60% of all the households with no children. 0.6 times each one, subtract 0.6 DNC, subtract 0.6 ENC, greater than or equal to 0. Nothing left on the right, so it means 0. Here's the one we skipped. So we're right where we left off. You ready? It says, the total number of households interviewed during the evening must be at least, so I'm going to stop right there. I like to write it just as I read it. The total number of households done in the evening. That means there's, I got to remember the variables. Daytime evening, EC is evening with children, and EC with represents evening with children plus no children evening. ENC. So there it is. There's the two variables. Here we go. The total number of households interviewed during the evening must be at least as great as. At least as great as. Greater than equal to, less than equal to. That's tough. Greater than equal to, at least as great as, the number of households interviewed during the day. So on the right side, it's all the interviews during the day, which happen to be these other two variables, which is DC plus DNC. Evening interviews added together has to be greater than or equal to daytime interviews when added together. We've got to get the variables from the right side to the left. We're subtracting DC and DNC from both sides now to get them over. And you end up getting, here it is, subtract the day on both sides, negative DC on the left now. Here's a negative DNC on the left, and you still got your EC and your positive ENC greater than or equal to 0. We just got the variables from the right side off to the left. And that finishes writing the constraints of the objective function. By the way, the objective function was keep costs down, $20 for every daytime with children, $25 every evening without children, or with children, excuse me, 18 without children day, 20 without children night. Then we solve it. Hang on. Oh, wait, I forgot. Did we look at the solver for this one? On this market research? Here it is. This is what you're handing in. A story we just read. You're writing out the objective function, you're writing out the constraints, and then you're creating this right here. I'm looking to see you have all this filled in, the right variables, the right-hand sides. Here's where the answer, the optimal values you're going to be. I'm looking at your formula here. I'm looking at you used either a min or max correctly. I'm looking at these formulas. I'm looking to see you put these. Look at the formulas here. These are looking up here and grabbing the numbers here. This, I made this one up. If you want to copy this and paste it into your Excel spreadsheet for each one of those, that's fine. I just made this up to come up with surplus or slack. It's a big if statement. I think I showed it to you already once, but I'll show it to you again. Like this is, wait a minute. Hang on. There. If F20 is looking back here, whatever the result here is, if F20 is equal to, well, right here, is equal to a less than, comma, if that's true, put the word slack there. But it wasn't true, so put the word surplus. And then I changed the formula once I realized I wasn't taking equal into consideration. Now it's this. We're looking at this cell right here, which is an equal sign. If F19 equals less than, comma, put slack. If it's not less than, comma, if it's not, then ask another if statement. If F19 equals greater than, then put surplus. But it doesn't. So the last option could be, and just put a blank there, because it's not surplus or slack, because this isn't equal, which means it will never have slack or surplus. That's a binding constraint anytime you have an equal. You're telling Excel, this has to equal 1,000, whatever that is, period. All right, so that's what you're going to use. Let's solve this. You ready? Daytime, how many daytime? I'm going to ask you how many evening, with children, without children. Solve it. We're going to data. Solver. I think I have it all filled out already. Blah, 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 blah. Look, I combined all of those greater than equal constraints right there because they were right in a row, so I was able to combine them. Anybody have a Mac and they're getting that dialog box? It's like a big blue box that's different than this. It looks different. Anybody have that? Not one person. What's your Excel dialog box? Does it look like this one, or is it this big blue thing?
Let me open it up. I don't think Mac.
Is there anybody that's never used what?
I don't think Mac has the solver.
It does. You have to install it. You got to go to Tools. You got to go to the last option down at the bottom of Tools. It will open up your dialog box. Click Solver. Hit OK. Give it a second to install. It'll be there. You go Tools. The very bottom one at the end says Add-ins or Add-ons or something.
Yeah.
And then it opens up a dialog box thing. Do you see Solver there? Click on Solver, that box, and then hit OK, and it will show up. Now I know what you have.
No, it comes up like solver parameters like yours.
Like this, yeah, okay.
Yeah.
Yeah, now it's installed. The students in the other section were using, you can still use a solver that's not installed a different way, and it's different. It's just, the same stuff has to be entered, and, but you get down to like the fourth item, and it's asking some really weird things that not on this one, so we figured out a way to get this one installed. All right, we're gonna solve this. I marked this box, I used the simplex in the method, solve, sensitivity analysis, sure. Okay, how many evening without children interviews do we need to get our people out there collecting? How many of the evening no children interviews? 360, you see it? ENC. How many evening with children interviews? How much is the lowest we could get their cost to get this research project done for our clients? $20,320. We then add 10% for the company, so that's an extra $2,000, what is that, $2,032? That's not enough. But that's really our cost. We're adding 10% to everything for our fee. All right, we're there. Now, we're going to get a little harder. Finance majors, finance majors, finance majors, thank you. Here's an example where it's used in finance. This is very common. A client's going to say, I want you to put together a suggested portfolio for me based on this information. You're writing notes, you're having it, or you're recording it, so you make sure you get exactly what the client wants. And the client wants, hang on, where is it? Consider, this mutual fund is located in New York. They just obtained $100,000, all right? To try and decide what to do with the $100,000, here's the investment opportunities for this fund. Based on their current investments, the firm's top financial analyst is recommending, you're the analyst, and you're recommending new investments, all new investments made up from the oil industry, steel industry, and government bonds. Specifically, the analyst has identified 5 investment opportunities and projected their annual rates of return. Right? Here's 2 oils, 2 steel, government bonds, projected rate of return. Now, the reason I'm mentioning this right here is because if we're including these percentages in a constraint or objective function, that's 0.073, that's 0.103, that's 0.064. I don't do that one. 0.075 and 0.045. That's how you would write them for your constraints or your objective function. You got to turn them into decimals. There's that information. They're saying, here we want neither industry, oil or steel, should receive more than $50,000. You ready? Out of all those choices, let's start with the steel industry. It cannot be more than $50,000. So my question for you is, less than equal, greater than equal, or equal to $50,000?
Less than equal.
Oh, I'm sorry, what is our variable? What decisions are we making here? What is the decision we're making here for the clients? What's our recommendation going to be in our presentation?
All industry.
No? Almost. What? No, this would be our variables, the decisions that are going to have to be made. Say it again? There's 5 variables. That's true on this one. There's 5 variables. What decisions have to be made?
MS stands for middle skill.
We can call it MS if you want, but we can call it anything you want, but you have to define the variable. I'm asking for that words where you would define it. If we call this A, let's say 11, what would A represent? How, when, what, how, yes? How much to invest in that investment. That's what we're coming up with. The optimal investment quantities, how much money in each of these. All right? Not how many shares, we're not even given the share price. It's how much money out of, how much money were we given? How much of that 100,000 is going to be split up based on these parameters we've been given. So there's your 5 variables. All right? To stay consistent, let me see what letters they're using here. A, P, M, H, G. Quit looking at that objective function. I already forgot it. Darn. What was it? A, P, they made sense. A, P, was it M? H and G? There's our 5 variables. Let's get to that. Let's get back to that first constraint. You ready? We're never going to make it for these. You can tell already. Neither steel or oil can receive more than $50,000. Less than equal or greater than equal 50,000 or equal 50,000. Can't be more than 50,000. Less than equal to 50,000. What is this 50,000? Dollars? Money? And what are these variables? Is this money or how many or what is this? How much? It's also money. So we don't have to convert to get money. On the left-hand side should be just the variables that represent oil to start with. I got to go back to the names of them. So, no, P, not a D. It's just only ones that are oil are A plus P. A plus P, however much is invested in oil, has to be less than $50,000. And then now let's do steel. Also, it says however much is invested in steel has to be less than 50,000. Which variables are steel? M plus H. There's 2 of our constraints right off the bat. Next says government bonds should be at least 25% of the steel industry investments. All right. It says government bonds, which is which variable? G. G. Doing it just like it reads. Should be at least less than equal, greater than equal. There you go. At least 25%, 0.25 of, so we know that's times, of the steel industry investments. Let me go back to the names. Which ones? M plus H. Now, when you write a constraint like this, you got to get the variables to the left side and have nothing but numbers on the right. So this is going to turn into 0.25 M plus 0.25 H. I'm going to subtract 0.25 M and 25 H from both sides, and I'm going to get negative 0.25 M minus 0.25 H plus G greater than equal to, what's left on the right? Nothing. Right? I subtracted this, I subtracted that on both sides. Next. Says, the investment in Pacific Oil, the high return but highly risky, cannot be more than 60% of the total oil industry investment. Which one represents Pacific Oil? Says P, let's do it just like it reads. The investment in P, which is a high risk, high return, cannot be more than, which would be what? Less than equal to 60%, 0.6 of times, whoops, the total oil industry, which is A plus P, is that what you just said? There's the total of the investments that would be in oil. You do this the same way, 0.6 times A, 0.6 times P, subtract 0.6A, subtract 0.6P on both sides. By the way, this is all done for you on here. And that is it, except for the objective function. Oh, what about the fact we only have $100,000? Is that going to be less than equal, greater than equal? They've asked us to invest every penny of that 100,000 must be invested. Less than equal, greater than equal, or equal to 100,000. And what's on the left? This is the amount invested in that plus P plus M plus H plus G. Everything invested has to equal $100,000. And then the objective function, we just found out from the client, they want to possibly get the highest estimated return. Where's our returns? The highest possible estimated return on the recommendation. Is that a max or a min? Max, because they want the highest. Go over here, max. Now we got to write this that represents the highest estimated total return. Jump in, Tim.
You don't have to move the A and P over.
Yes, I do. I said it out loud, but I didn't write it.
Okay.
You want me to write it out?
No.
You gotta take a 0.6 times A, which is 0.6A. I'm sorry?
Do you write it out?
Okay. So this turns into 0.6A plus 0.6P. Now I'm gonna subtract each of those from both sides. What do I have left here? So I'm gonna have, I'm gonna put an arrow here. So, can everybody see? P, well first I got that 0.6A I gotta subtract, so minus 0.6A. Now I've got 1P minus a 0.6P, leaves me with a positive 0.4P. Less than or equal to, nothing's left there, 0. Everybody see where I got this 0.4P? I was subtracting 0.6P, but there was a P on here, a whole one. So 1 minus 0.6 leaves me with the 0.4. Now we're back to the objective function. I got to take each variable and have it represent the estimated rate of return. So I'm going to grab those. I can't read them. 7.3, 0.073A plus, what's the next one? 10 something?
0.103.
0.103
Yeah. B.
M plus.
Oh, that's a B.
P. The next one down is 6.4, 0.064 M plus 0.075 H plus the last one is 0.045 G. That's what we're maximizing. However much money we put into each of these investments times how much they'll earn after a year goes by, estimated based on historical information. That's what we're trying to maximize, that estimated rate of return for our client. So here we go. Here's the variables. There's the objective function we just did. All the different rates of return. Here is equals $1,000, every variable added together. The oil industry, less than or equal to 50,000, just the oil. Steel industry, less than or equal to 50,000, just the steel. Here is before algebra took place, 25% of government bonds has to be more than 25% of all the money put in the steel industry. Here's the specific oil. The amount put into that one oil company has to be less than 60% of all the money they put into oil. And that's it. And then we solve it. Here it is. If you're gonna, your homework is to write it out like this from the story you read in the book on that problem. And I want to make sure to point something out, by the way. It just dawned on me. When you're looking at problem 3, for example, part of, I mean, you know, you got to read the whole problem to grab all the information. And that's why I gave you the hints how many constraints you're going to have. Because on problem 3 is separated in different parts, kind of. And if you're going, God, there's got to be one more constraint, because the hint says there's this 5 constraints. You just got to keep reading, you'll find it. Okay, it's in there, the information's in there for all 5 constraints, or 4 constraints, whatever the hint says. That's why I gave you the hint, because it can get confusing. But this one now is this one right here. Here it is. This is just like you're handing in if you only have one sheet. You have 2 and 3 of them. This is what I'm looking at. Your work, your work. Here's our 5 variables. These numbers are just like each of the constraints. There's our objective function numbers. Here's where our optimal solution is going to be. My question is, out of $100,000, how much are you going to put into the steel industry? Which ones are steel? A and P or M and H? M and H. How much are you putting into the steel industry? E16, just double checking them. They look good, I think. What's that? What's that? All right, let's check it out. Hey. How much are we going to invest? What? What just happened?
Do you have the market research one over?
I know, it did it on its own. So when you go to solve it, it's going to jump to a different spreadsheet. Let's see if it does it when we do that. We have one more to solve. How much are we putting into the steel industry? 40,000, right? You said it's M and H. Zero's going into M, 40,000 to H. That's 40,000 in the steel industry. How much is going into the oil industry? What letters are you looking at? A and P. So how much? 50,000. Look at it. Couldn't go over 50,000. It said this is where the return's at. We're putting exactly 50,000 in there. Is what the results said. What is the? What will be? I gotta make sure I say this right. As a matter of fact, it's kind of blurry with me. What will be the amount of money we will make under this suggested portfolio of these 5 investments after a year's time, what's the most we can make off these, based on these constraints? Yes, $7,550 on the 100,000. What will be our rate of return if this is the result? What's the math on it? Finance. There you go. You take the amount you made, which is $7,550, and divide by the initial investment at the beginning of the year, which was how much money was this? 100,000. You're gonna, which just moves the decimal over. Boom, boom, boom. So it's gonna be 7.55% return on your investment. Right? Does that sound right? That sounds exactly right. Because I was thinking 70,000 would be 70% of 100,000, so that's 7%. All right. How much we put in government bonds? Only 4.5%. Anybody see it? 10,000. Where the G is. Well, I'm not prepared for the next quiz, because on the next quiz, you're going to have an output where you're going to be asked questions like, how much are we investing in the oil industry? And I want to see that you can read the output. You're going to go from the story to the constraints and the objective function to the output and answer questions. You're going to be able to tell if you've read the question, what each variable represents on the output, and be able to answer the question. It's showing me you know where to look to find these answers. That you're putting now, you're putting all these numbers into what does it mean. I look at constraint 3, and I see that it's 40,000 here, 50,000 here with 10,000 slack. What does that mean? What is this 40,000? What is this 50,000? What is it we're trying to accomplish in that constraint? Do you remember what that constraint represents? Yeah. Seriously? What? It's the third constraint down. Look up here. Look at where the ones are. It almost gives it away what it represents right there. So I heard it. Steel. Remember the constraint said, however much we invest in the steel industry has got to be less than 50,000. The slack then represents of 10,000 represents what? That we met the constraint. We're at 50,000 or less. As a matter of fact, we have a $10,000 cushion if we need to put more money in steel. We're so far below the 50,000, there's even a $10,000 cushion there, and still be at 50,000 or less. All right, you guys are scaring me. Are we recording this? Now we got witnesses. All right, last one. I posted this. Right? Is this the last one, or did I skip one? We're right on schedule. You ready? The story's over here. Floataway tours. That's you. Your floataway tours. I had some friends when we graduated from college. When they graduated a little after I did. They said, we're taking a year off. And we're just going to, they just wanted to go to the beach and get drunk every day, smoke as much pot as they can for a whole year. They said, that's how much we had at school. And sure enough, one didn't make it the whole year, came back. They went to the Virgin Islands. Came back, got a job, got back to real life, married, kids, all that stuff. The other one stayed and said, no, I'm not leaving. This is too heavenly. It's like no law here. You can get drunk all night long. The bar doesn't even close. And said, I'm going to start a business. And it's going to be, every time the cruise ship stops and they get off the boat, they want to rent little boats to ride around the islands and check things out. So you start this floataway tour company. So up to that point, it was a true story until I got this. And you start this floataway tour company, and you realize, man, I only got a couple of boats in this thing. I can't keep up. I have people in line waiting for a boat to come back in just so they can rent it. So you secured a loan. By the way, most commercial loans, you need to save 10% of however much you're about to spend and try to borrow the other 90%. They're going to ask you for skin in the game, they call it. I always got that at commercial lenders. We need your company to have skin in the game. Meaning you're putting up some of your hard cash, and if things don't work out, yeah, we put up most of the cash, but you're going to lose too. It gives you motivation to make sure you try to work as hard as you can to work out so you pay the loan back. And you went ahead and secured between your money and the loan $420,000. And you're going to expand your business by buying additional boats because you've already got the space in the dock space that you're renting. You just need the boats so you can capitalize on all this demand. So here's the deal. You are going to buy from two different manufacturers because when you started this business, they're the ones who helped you get things started. And so you want to be loyal to manufacturers. And this is real life. This company, this computer company, in order for us to show loyalty like to Intel and to AMD, we would do things like this. We would kind of take an order and split it up in a way, or different things we would do to show loyalty. And what you get in return is loyalty in return, all kinds of benefits. For example, when we ran commercials, anybody ever watch a commercial for a computer company? At the end, you hear that little bell, ding, 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 and then the Intel symbol comes up. Just to have that at the end of the commercial, they would pay for 90% of the commercial that we would run. Just to make sure that ding, 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 Intel is at the end of it. That's the kind of things they would give to you because, hey, you've been loyal to us. You've been buying your processors, your memory through our supplier. And that's what's happening here. You're getting some benefits from these manufacturers who helped you get started and are going to help you get through the trial and errors of running the company now with all these different bolts you're about to buy. And so to be fair, here is the deal. You want at least 50 bolts total, and there's 4 bolts to choose from. And you're buying at least 50. So however much money you're spending on each bolt, on a 420,000, it needs to be spent in a way that will get you 50 bolts. And you want to buy the same number from one manufacturer called Sleep Bolt as you're going to buy from Racer. That's how you're showing your loyalty to these manufacturers who give you all kinds of stuff to help your company take off the way it has. There's 2 options from Sleep Bolt, 2 options from Racer. You want to buy the same amount from each of them. Think about that constraint for a minute. Let's see. 50 bolts from each of them to show goodwill. At the same time, you wish to have total seating capacity, whatever combination of 50 bolts you're buying, and here's the seating capacity for each one. When added all up, you want it to be at least 200 seating capacity total out of those 50 bolts. All right. Your objective is to get as much profit as possible, but still have at least 50 bolts and still have seating capacity for 200. You're only spending 420,000, but you want as much profit, and you know from the boats you have already, the couple of boats you have, how much profit you'll make off of each one of these boats because of this seating capacity. And you know what you can rent it for. You know your costs. You already got this business up and running. You're about to expand. Let's start with the objective function, or variables. How many variables do you see now that's all set up over here for you? 4 variables, x1, x2, x3, x4. That's going to be these 4 bolts right in order here. All right? Now, let me look at here. We want at least 50 bolts. Each variable represents how many bolts of that exact kind we're buying. X1 is how many Speedhawks made by Sleep Bolt. X2 is how many Silverbirds made by. Everybody get where I'm going here? So now, we, what did I say, 50 bolts. I need to turn that into a constraint. Less than equal, we need at least 50 bolts. Less than equal 50, greater than equal 50, or equal to 50? At least 50 bolts is greater than equal to 50. The variables represent how many bolts already, so x1 plus x2 plus x3 plus x4 greater than equal to 50, or 1 underneath x1, 1 of those, I'm sorry, I'm up here. 1, 1, 1, 1. There it is, 1, 1, 1, 1. Greater than equal to 50, there's the 50. This next one's a 0. Now here's why. This constraint is all about that you want to buy the same number of bolts from Sleep Bolt as you do from Racer. You've got to write a constraint that the number of bolts you buy from one equal the number of bolts from the other. I've given away the constraint, less than equal, greater than equal, equal. So on the left side, x1 plus x2 are the total number of bolts we'll buy from one manufacturer, and we want it to equal exactly the bolts we'll buy from the other manufacturer. So I wrote it out just like it said, the same amount of bolts from one as the other. Now use algebra, because you can't have variables on the right side. So I'm subtracting x3 and x4 from both sides. I get x1, whoops, hang on, x1 plus x2 minus x3 minus x4 equals 0. And that's why you have 1, 1, negative 1, negative 1 equals 0. Everybody get it? Next one, we need 200 seating capacity. at least 200 out of these 50 boats. Less than equal, greater than equal, or equal? Greater than equal, at least, I'm sorry, 200. Seating capacity. These variables represent how many boats we're going to order, not the seating capacity. We've got to convert them to represent. For every Speed Hawk from Sleek Boat we buy, we will gain how many seating capacity?
3.
So 3 x1 plus how many for the next boat? 5 times x2 plus how many for the third boat? 2 x3 plus, can't see it, 6 x4 greater than equal to 200. I think that's it. Let me look. Oh, the money. The money. Now let's think about it. Do we have to spend all 420,000 on these boats? Do we have to spend every penny? Does the loan, does the bank say, now look, we're lending you, you came up with 42,000, we're lending you the other 300 and whatever thousand. Are they going to say to us, you have to spend it all? No. So less than equal, greater than equal, or equal? Less than equal, 420,000, but the variables represent how many of each boat. We got to convert the variables to how much we'll spend for each boat. The cost for the first one is, was that 6,000? So 6,000 times x1, however many x1s times this price, plus, I can't see the cost, 7,000? 7,000 x2 plus 5, is that 5 or 55? 5,000 times x3, that's a 5. And the last one cost is the big boat, which costs the most, say 8? 9. 9,000 times x4, less than equal to 420. That is all our constraints. 420,000, 50, 0, 200. Oh, our objective, profit. Profit. Max or min? I'm losing space here. Max. X1's got to be turned into profit. What's the profit on X1? $70. 70 X1 plus 80 X2. We have big profit on the fourth one. What's the third one? 50 X3. Big profit here. What is it? 110. Give me those bulls. Work less with more money. So we got to spend a lot more for it. So it's about the return on the investment. Now we got everything here. All right, let's solve it. My question for you is, how many are we buying from each supplier? Are we truly buying the same amount from each of them? Okay, here we go. Data. What happened? Data. Solver. Blah, blah, blah. It's all filled out. Solve. Sensitivity, sure. Give it to us. How many boats are we buying? Wait a minute. Every time it switches screens when you go to solve. If you have multiple screens up, is that just my computer or is everybody? You guys have no idea. You've never solved them. You all get effort to solve them. You never did. No, just kidding. Here we go. How many boats are we buying from each supplier, and are they the same amount from each one? How many from each one? Each. 28 from each one. Are we buying at least 50 boats? We're buying how many? 56. 28 from each of them. How many Catman from the racer company are we buying? 0. So we're going with nothing but the Speedhawk and the Classy. Is that correct? And how much profit if we go with just those two boats? 28 of one boat, 20 of the other. We're hugely expanding our business. I can't even wait for these to arrive. We've been drinking beer all summer, and now we got real work ahead of us. And how much profit will we make? What's the most amount of profit we can make off this combination? 5,000 at a day. This is your average daily profit. If you rent all these boats out in one day, it would be $5,040. Now your payment on that 420, by the way, I'm going off the top of my head, it's been a long time, but I'm going to guess that you are going to be spending $4,000 a month on your loan payment. A month. So if this is daily profit, we should be okay, right? I mean, we got a whole bunch of other stuff. We got employees. We got to keep the boats maintained. Tons of fuel for all these boats to be rented out. So we got expenses involved. And don't forget, we incorporate, so we got to pay ourselves a salary. As the company makes money, if we take money out of that, it's called a dividend distribution. Accounting majors, finance majors. Ready for the in class? Are we ready? We made it.